Hello again. So in the last video we had exported the historical earthquake data values in our existing visualization. So now that we have the historical earthquake data, we are going to categorize these data points based on their magnitude. That is, higher the magnitude of the earthquake, larger these data points should look like. So for that, we are again going back to the layer styling menu. If you don't have this open, then you can click on this and this will open up your layer styling tab over here. And this over here, it denotes which layer you are in. And over here, we are again going to choose graduated. And we are going to choose magnitude because we want to classify these data points based on their magnitude. That is, larger the magnitude of the earthquake, larger the data points should look like. So over here in the method, I'm going to put it as size. And the size is going to range from 1 to 8, and that's because, the earthquake value that we have is, the largest we have is 8. So I'm going to do classify. So you see it over here. We see that there are larger larger circles which indicate that this area has the historic record of large magnitude of earthquake that came into this area. And yeah, so and we have this very earthquake of very small magnitude happening in this area a lot of the time in the past. So okay, but here's one thing I'd like to do. I'd like to change maybe the color, but before that, let us take care of the transparency. So I'm just going to put it, going to get it to 50, and I'm also going to make some change. I don't know if you are okay with this color that I have over here, but yeah, maybe I'll change it to some other color, maybe to blue. Yeah. Okay. Yeah, I think this is better. I mean, this is totally up to you. I mean, I did not really like the maroon color previously for the earthquake data points, so I just changed the color, but that is totally up to you. And okay, so now over here we have a graph. I mean, this is how our final graph looks like. We have the we have a visualization that represents the seismic activity in the area of the United States. And we also have, and in the same graph, we have also mapped the historical earthquake data values. And with the earthquake data values, what we have done is we have classified the data points based on the magnitude. So higher the magnitude of the earthquake in the past, the larger the circle looks like. So over here, we can see that this area, I mean, we don't really have the information of the seismic activity over here, which is a part of the Canada, but just by looking at the data, we can tell that this area had in the past, this area had an earthquake that was very high in magnitude. But coming back to our map of United States, which is the data that we have for the seismic activity, we can say that this area over here does have a high seismic activity going on, but based on the historical data, we can say that this area did have earthquakes in the past, but they were very small in magnitude. And over here, this area of the United States, this area does not really have any seismic activity going on, and based on the historical data, we also don't have any information of the earthquake happening in that area. But over here we do have some seismic activity going on, and around these areas, around the proximity of this seismic area, we do have, small earthquake of small magnitude happening at times. Over here we have, let's zoom in. So over here we do have the information of seismic activity going on over here, and based on our legend or labels over here, we do know that this area does have a high seismic activity going on, and this area did have earthquakes of medium size happening, and this one over here looks like there was an earthquake of the magnitude of 6.8 to 7.5 that has gone in that area. And if we go to the San Francisco, California area, we can see that this particular area, it has very high seismic activity going on, and based on the past historical earthquake data, we can say that this area had earthquakes of huge magnitude that has gone in that area. And likewise, the same over here, we have like earthquakes of both small magnitude and high magnitude going on in here, and this area seems to be a high risky area because we do have the information of high seismic activity as well as high magnitude earthquakes of high magnitude that has happened in the past in that area. So now that we have the information that we have collected utilizing the seismic area activity and the historical earthquake data, the question is, how can this information be utilized by the insurance companies to make their policies? So the use case is that, one of the use case of insurance companies is that based on the similar kind of analysis that we just did, they can make their policies on how much premium are to be collected from the people living in a certain area. So the analysis that we did in today's class is called the risk assessment analysis, which is an analysis that is very extensively or very heavily used by the insurance companies. So based on these areas, the information that can be utilized by the insurance companies is that people living in the San Francisco or California area, if they ever decide on getting the earthquake insurance from the insurance companies, these insurance companies, they have a very valid ground to charge high premiums from the residents living in this area, because this area, they have very high seismic activity going on, and the historical data shows that they also have had earthquakes of magnitude ranging from high to low Richter scale in that area. So that is the kind of information that can be used by insurance companies to insurance companies using location data, and that is how much premiums are to be collected from the residents of a certain area. And again, the similar kind of analysis or the similar kind of risk analysis that we just did for the earthquake risk assessment, this can also be used by architecture, that is builders or the real estate companies, or even the policy makers at the government level. So this analysis can also be used by the builders or the government level employees to make policies on the building codes that needs to be established for a certain area, as in the building codes based on the seismic activity for certain areas. So meaning that if ever the government or the San Francisco policies decides on making new building codes or developing new building codes for the California area or the area where there are high seismic activity and where there are huge earthquake magnitudes happened in the past, they can use similar kind of risk analysis to determine what kind of building codes should be developed in that area to make sure that the buildings are earthquake resistant. So this is one of the use case of insurance companies, and also the use case for the builders or the architectures. And this analysis that we just completed in the class is called a risk analysis or the risk assessment, which is very heavily used by the insurance companies. And there are also other use cases of the insurance, other use cases of the location data of the by the insurance companies, such as fraud detection and all. I will provide the examples of other use cases by the insurance companies in the handout. So meanwhile, if you have any questions, please do not hesitate to reach me out, and I'll also provide further instructions on how the proposal or how the final project should look like. Just really quick, for the final project, I'd like you to carry out the project individually, because I think that's going to be more helpful, because I can't really see a very so far, based on the proposals that I have received, I don't think the proposals or the magnitude of the project is so huge that it would require 3 to 4 people to work in. So what I'd like you to do is I'd like you to work on a project individually, and the project final project paper should be around like 3 to 4 pages long, and I'll provide like further details, but just wanted to give you this quick info. So yeah, so thank you so much for the video, and thank you so much for watching the video. Sorry. And yeah, so if you have any questions, please let me know. I'll be very happy to answer your questions. And yeah, thank you so much, and I hope you have a wonderful weekend.